It is 11:38 a.m. on January 28, 1986. The ground at Kennedy Space Center begins to shake. A pillar of fire erupts from the launch pad, pushing 2,000 tons of machinery into the frozen Florida sky. To the millions of people watching on TV, this is another perfect American triumph. But there's a secret. A handful of engineers in a dark room are watching the monitors in terrified silence. They know something the public doesn't. So much so, they refused to sign the launch recommendation and begged NASA to stop. But the agency didn't. 73 seconds later, the sky turned into a twisted cloud of white smoke. The public is mortified, but before the debris even hits the water, NASA is already trying to bury the truth. They want the world to think this was a tragic accident, a stroke of bad luck, yet it wasn't. Today, we all know why and how the Challenger shuttle exploded, but to me, this is just a technicality. The real question is, how did an organization built on safety first twist its logic so severely that they convinced themselves a red flag was actually a green light? How exactly did the dream of the teacher in space become a deadly, fiery nightmare? This is the story of how NASA tried to cover up its worst disaster. And the object that exposed everything was a simple cup of water. When the space shuttle was first conceived, it wasn't sold as a shiny new rocket. It was sold as a space truck. NASA officials promised Congress that they would launch shuttles 60 times a year, literally more than once a week. They wanted to haul satellites into orbit like a trucker hauls cargo across the interstate. But by 1986, that dream was collapsing under its own weight. The shuttle was an engineering marvel, sure, but it wasn't made of vibranium parts. It required thousands of hours of maintenance between flights. Instead of 60 launches a year, NASA was struggling to manage just a handful. The mission right before Challenger, which carried Congressman Bill Nelson, had been a public relations nightmare. It was scrubbed and delayed 7 different times. It became a running joke on the nightly news, and the criticism stung. By January of 1986, NASA didn't just want a successful launch. They were desperate for a win to prove they were still the best in the world. That win was supposed to be the Teacher in Space project. This was NASA's masterstroke. See, the public had grown bored of watching test pilots and scientists float around. The magic of the moon landings had faded, so NASA decided to send one of us. Out of 11,000 contenders, they chose Krista McAuliffe, a high school social studies teacher from New Hampshire. The excitement around her was electric. She represented every civilian who had ever looked up at the stars and dreamed of going there. And not just going. Her assignment was to teach a lesson to millions of school children from orbit on day 4. But the exact date once again started slipping down the calendar. Challenger was originally supposed to lift off on January 22nd, but then the delays started piling up. On the 23rd and 24th, dust storms at an emergency landing site in Africa forced a scrub. On the 25th, there was rain. On the 26th, bad wind. And then on January 27th, they faced the most absurd failure of all. The crew was strapped in, ready to fly, but the ground crew, couldn't lock the door. A single bolt on the exterior hatch handle was stripped. They tried to drill it out, but the drill battery died. Then the backup battery died. They eventually had to use a hacksaw to cut the handle off. By the time they fixed it, the wind had picked up and the launch was scrubbed. A stripped bolt, a piece of hardware you could buy at a hardware store, had grounded the most complex machine ever built. The frustration inside NASA was boiling over. Every single delay was a headline, and every headline was an embarrassment. Worst of all, the clock was threatening the whole teacher in space thing. If they didn't launch by Tuesday, Krista's live lesson would be pushed to Saturday when no kids were in school. The value would be 0. So when the sun rose on Tuesday, January 28th, the pressure to go was absolute. The crew of 7 walked out of the operations building to the flashing of cameras. Krista McAuliffe was smiling. She was ready to make history. They had no idea that outside that hatch, the only history being made was a series of fatal decisions that had already sealed their fate. The mood in the Kennedy Space Center was grim. A massive cold front was sweeping south, turning Florida into an icebox. The forecast for launch morning was -8 degrees Celsius. For a tourist, that's just bad weather. But for the space shuttle, a test of survivability. You see, the solid rocket boosters weren't built as one single piece. They were made of giant steel segments stacked on top of each other. Where those segments met, there was a gap. To keep the explosive gases from leaking out, they used 2 giant rubber circles called O-rings. When the rocket ignites, the pressure pushes the rubber into the gap, sealing it shut. But rubber has a weakness. When it gets cold, it loses its bounce. It gets hard. And the engineers from NASA's subcontractor Thiokol, who built the boosters, knew from data they had seen a year earlier that if you freeze these rings, they might not seal in time. So, on the night before the launch, the engineers called NASA. They drew a hard line in the sand. Al McDonald, the director of the booster project at Thiokol, along with fellow engineer Roger Boygely, got on a 3-way teleconference with NASA management. They laid out their charts and photos with signs of erosion from previous flights. They said the boosters were not qualified to fly below 12 degrees Celsius. -8 was a risky, uncharted territory. The engineers gave a specific recommendation: do not launch. But NASA's reaction wasn't gratitude for the safety warning, it was anger. On the other end of the line, Lawrence Malloy, a manager for the booster program, felt that engineers were changing the rules at the 11th hour. He famously snapped back, "My God, when do you want me to launch? Next April?" Another manager said he was appalled by the recommendation to cancel the launch. So they grilled the engineers, demanding they prove the rocket would fail, rather than asking them to prove it was safe. The Thiokol executives in Utah asked for a 5-minute recess to go offline. They muted the phone. But they didn't use that time to look at the data again. They used it to look at the politics. The general manager turned to Roger Boygely and told him to take off his engineering hat and put on his management hat. In the end, management caved. They came back on the line and told NASA they had reconsidered. They were go for the launch. But down in Florida, Al McDonald was furious. He refused to sign the launch recommendation. This was an act of defiance that should have stopped the countdown cold. But it didn't, since NASA just bypassed him. They had his boss in Utah sign the paper and fax it over. So you could just do that? Why not launch every rocket on a hunch of the PR department then? Anyway, that day the system had won and the engineers were silenced. By the time the sun rose over the Atlantic, the paperwork was signed, faxed, and filed. The arguments were over. The decision was locked in. Out on Launch Pad 39B, the ICE team was walking the gantries, measuring freezing temperatures, and looking at literal icicles hanging off of the service structure. They had never seen a shuttle sitting in a freezer like this before, but the countdown clock kept ticking. Soon enough, the crew was strapped in, totally unaware of the midnight fight that had raged while they slept. The people that were about to fly the spaceship didn't know that the engineers who built their ride had begged NASA to keep them on the ground. In other words, those who risked their lives for NASA weren't told by NASA about the true amount of risk they were taking that morning. unbelievable. The engineers who had screamed stop were now just helpless spectators standing in the control center, crossing their fingers and watching their worst fears ignite. 3, 2, 1. The entire shuttle stack, 2,000 tons of metal and fuel, leaned forward in what engineers call the twang, a massive shuddering bow to the laws of physics. Then, as it snapped back to vertical, the solid rocket boosters ignited. For a fleeting moment, as the clamps released, it looked like a triumph. But the cameras on the launch pad saw something the human eye missed. At exactly 0.678 seconds, a puff of black smoke jetted out of the right booster. That was the ghost of the argument from the night before. The cold O-ring, frozen hard by the -8 weather, had failed to seal. It let hot gas escape. But then a stroke of blind, dumb luck intervened. The solid fuel creates a byproduct called aluminum oxide slag. At 2.733 seconds, this melted slag gets caught in the gap and plugs the hole. For the next minute of the flight, the only thing keeping the crew alive is a fragile plug of accidental debris. 7 seconds in, the shuttle clears the tower and begins its roll maneuver. Inside the cockpit, everything feels normal. Commander Dick Scobie and pilot Mike Smith are watching their instruments. The G-forces are building, pressing them into their seats. They throttle the main engines down to 65% to pass through the thickest part of the atmosphere. At 58 seconds, nature played its cruel card. The shuttle hit max Q, maximum aerodynamic pressure. But on this specific day, the sky was violent. The shuttle was hammered by the strongest wind shear ever recorded during a launch. The jet stream was battering the vehicle, pushing it sideways, forcing the guidance computer to swivel the nozzles just to keep it flying straight. That violent vibration was the killing blow. It shook the booster just enough to shatter that little plug of slag. The seal broke for the second and final time. At 59 seconds, a tongue of flame hot enough to melt steel shot out of the side of the booster like a blowtorch. It was pointed directly at the giant orange external fuel tank. Incredibly, it took 9 seconds before the flame burned through the hydrogen tank's skin. Inside the cockpit, the crew was still unaware. Commander Scobie hears the call from Houston. "Challenger, go at throttle up." He responds, "Roger, go at throttle up." Those are the last words anyone on Earth will ever hear from him. At a little more than 72 seconds, the flame burned through the lower strut holding the booster in place. The bottom of the massive rocket swung free, pivoting on its nose. It slammed into the top of the hydrogen tank. In less than a second, the tank collapsed, mixing liquid hydrogen with liquid oxygen. The resulting fireball tore the Challenger apart. To the millions of children watching in classrooms, it looked like an explosion. But the terrifying truth is that the shuttle itself didn't blow up. It was torn into pieces by the sheer force of the air hitting it at twice the speed of sound. The wings ripped off, the tail ripped off, but the crew cabin was a reinforced pressure vessel. It was built to be the strongest part of the ship. At 75 seconds, it actually snapped off the fuselage in one piece, intact, and was thrown clear of the fire. It continued to fly upward on its own momentum, climbing to a height of almost 20 kilometers before gravity took hold and pulled it back down. And this is when it gets not just tragic, but haunting. When investigators later recovered the wreckage from the ocean floor, they found the personal egress air packs, the emergency oxygen supplies. 3 of them had been manually activated. One belonged to the pilot, Mike Smith. But here's the twist. The switch to turn on his air pack was located on the back of his seat. He couldn't reach it. That means someone else, likely Judy Resnick or Ellison Onizuka, who were sitting behind him, leaned forward in those terrifying seconds after the breakup and turned it on for him. The crew actually made a rational, trained response to the emergency. Not that it mattered anyway. High above the Atlantic Ocean, they were strapped into their seats, unable to steer, unable to radio for help. And in the middle of that falling cabin was Krista McAuliffe. She had spent months preparing her lesson plans. She had practiced how to demonstrate liquids in zero gravity. She had her lost lesson memorized, ready to broadcast to students who were watching live on TV right at that moment. The children in her own classroom in New Hampshire were wearing party hats, cheering as the rocket went up and then falling into confused silence as the smoke cleared. Krista, along with the Challenger crew, had absolutely no chance of surviving the fall from a height of more than 2 Mount Everests. At 2 minutes 45 seconds after launch, the ocean swallowed the crew cabin. Meanwhile, a different kind of silence fell over NASA. The control room instantly went into lockdown. Flight Director Jay Green ordered the doors bolted. He ordered the phone lines cut to the outside world. Managers ran through the halls, confiscating every piece of data, every printout, every logbook. The official reason was to preserve evidence, but the effect was to seal the building tight. For an agency that prided itself on transparency, their first instinct wasn't to share the truth, it was to control the narrative. When the Presidential Commission, led by former Secretary of State William Rogers, arrived 4 days later, NASA management tried to paint a very specific picture. Lawrence Malloy, the same man who had snapped, "When do you want me to launch?" just hours earlier, took the stand. He testified that the launch decision had been normal. He claimed that there were no major safety objections. He told the commission that the contractor had voluntarily agreed to launch. So the narrative painted the Challenger disaster as just a tragic, unavoidable accident. But sitting in the back of the room was Al McDonald, the engineer who had refused to sign the paper. He listened as Malloy and other officials omitted the most important event of the night, the fight. So he approached the commission investigators and told them, "I think you should know that Thiokol originally recommended not launching." The room froze. In that moment, the entire NASA defense crumbled. McDonald handed over to Chairman Rogers the notes from the midnight teleconference. He exposed the bullying, the pressure, and the management hat comment. Suddenly, the investigation shifted from what broke on the rocket to what broke in the system. But the final nail in the coffin came from a glass of ice water. The commission included legendary physicist Richard Feynman. He was tired of NASA managers using vague, complex language to hide the truth. So, during a televised hearing, he did a simple experiment. He took a piece of the O-ring rubber, clamped it, and dropped it into his glass of ice water. He let it sit for a few minutes, then pulled it out and undid the clamp. The rubber didn't bounce back. It stayed crushed. In mere minutes, Feynman, using a cup of ice water, proved what NASA had spent months trying to deny. You would think that after such a public exposure, the people responsible would be held accountable, but that's not how bureaucracy works. Lawrence Malloy and the other managers who pressured the engineers faced no criminal charges, most simply retired or transferred. But Alan McDonald, the man who told the truth, he was punished. His company demoted him and assigned him to a scheduling job that didn't exist. He was treated like a traitor for saving the integrity of the program. It took the direct intervention of the U.S. government to shame the company into giving McDonald his job back. Eventually, he was put in charge of the redesign, and he made sure they did it right this time. They added a third O-ring to each joint. They installed heaters to keep the joints warm no matter the weather. They stopped treating the shuttle like a commercial delivery truck and started treating it like the dangerous experimental vehicle it always was. The Challenger disaster changed the way we fly, but the cost of that lesson was far too high. It was paid for by 7 people who trusted that when the experts said go, they actually meant it and would never, ever try to cover up their blunders. years. You would hope that after fixing the seals and firing the managers, the danger would be gone forever. And for 17 years, the system worked. But in 2003, the destruction of the Space Shuttle Columbia reminded us that spaceflight is never truly safe. Yet, in a strange way, looking back at it actually makes the Challenger story harder to swallow. Columbia broke apart over Texas because a piece of foam struck the wing during launch. It was a truly random, chaotic stroke of bad luck. Once the shuttle reached orbit with a hole in their wing, the fates of the crew were sealed. There was no meeting that could save them, no phone call to make to fix everything. That's what makes the Challenger disaster so infuriating. NASA had people literally begging to stop the countdown. That disaster was a failure of will. The shuttle program eventually came to a close, but not before NASA did something that felt like closing a wound. In 2007, they sent Barbara Morgan to the International Space Station. She was Krista McAuliffe's backup in 1985, the woman who trained right alongside her. But eventually, it was Barbara who became the first teacher to ever go to space. When she finally turned on the camera and taught that science class from orbit, she proved that Krista's dream didn't die at the bottom of the Atlantic Ocean.